Consumers want to know the facts about the products they buy, but America's agricultural landscape is not easy to navigate. Between different companies, scientific advancement, government regulations, advertisement campaigns, and an unhealthy amount of myth and misconception, anyone would be hard-pressed to make sense of it. That's where Real Ag comes in. Kyle Bauer and the Real Ag crew bring you truthful, unbiased information about real agricultural concerns. From the producers who make your food, to the store where you buy the final product, and everything in between. This is Real Ag. Now, here's your host, Kyle Bauer.
Are you concerned about vaccines in the meat that you serve your family? Well, grab a seat because today we're diving in and telling you everything you need to know. Vaccination of food animals is our topic today on Real Ag.
Production of Real Ag is made possible by
Servitech has been helping producers across the Midwest make the planet more productive since 1975. We are proud sponsors of Real Ag, helping tell the story of how your food makes it to your plate.
The Kansas Soybean Commission, the Soybean Checkoff, progress powered by farmers.
What are vaccines?
If we look at what a vaccine is actually a tool we use to prep the immune system to prepare it before it becomes in the face of disease. So when cattle are exposed to disease, there's always pathogens or bugs in our environment that they're exposed to. We need to prep that immune system to prepare it so when it does come across this disease, it doesn't get sick.
So it's an antigen, so it's particles that you're introducing to the immune system of the horse or cattle or any animal really that hopefully stimulates their immune system for protection. So it is not an antibiotic or anything else. It is completely different in that it actually aids in boosting the immune system for recognition to certain diseases.
So when we make a vaccine, we take an antigen, which is a protein, naturally found in the environment, naturally found in the bugs that are out there, attenuating or killing or making it non-lethal, non-pathogenic, or lacks the ability for the animal to get sick, putting that in the animal so they can then trigger the immune system to make a roadmap to respond to that antigen, to that bug. And when they make that roadmap, then they've got protection, they've got an ID there set that they can pull up later and say, okay, this doesn't belong here, I can respond quicker.
Most vaccines are very specific on certain diseases that they're trying to protect for. And depending on what species you're talking about, that could include any respiratory type viruses. There are some bacterial vaccines that are out there too to help hopefully protect them from different diseases. Other things that might cause neurologic diseases, black leg, those kind of things, or also bacteria that we're trying to prevent some of these cattle from getting, especially at a young age, tetanus. Just like you and I as humans, we get vaccinated for tetanus. A lot of the animals get vaccinated for that too, if they get a cut or scrape, or just trying to prevent that aspect too. So how it boosts those things is specifically whatever is in that vaccine. So it is either particles of the virus. Some vaccines are modified live, meaning that the vaccine is a weak strand of the live virus. And so you are inoculating that animal, or even you and I, we sometimes get modified live vaccines. And what it does is it boosts the immune system without causing disease. Or if it causes the disease based on modified live vaccine, it's very subtle because it's a weak type of modified live virus or some aspects of a bacteria that just boosts the immune system to that specific disease for that host, meaning either cattle, horses, or even small animals.
So if you look at a plane crash and you have your EMTs in town, they do in your county, and they do a practice response, they do it with a mock wreck, That's probably about as good as an analogy you can get to a vaccine. It's a mock disease challenge. And in doing that, the immune system of the animal is more prepared to react to that disease challenge when it comes up, when it shows up.
What sort of regulations exist for vaccines?
I think the biggest thing that most people don't understand is the amount of regulation and research and safety for our food chain here in the United States.
Okay, so if we look at the difference between vaccines and animals and people, the first thing is, and probably the only difference, is how they're regulated. I mean, human vaccines are regulated by the FDA, Federal Drug Administration. Animal vaccines are licensed and regulated by the USDA. When we look at interactions we look at vaccine regulations, every vaccine has to be approved and licensed. And in doing so, they have to prove they're safe for both the animal and the public, and efficacious in that they do what they say they're going to do. They protect against what they're vaccinating them for. And in doing that, the USDA oversees that. There are strict regulations in both vaccine production. So when we produce a vaccine, we actually have to check every lot that comes out. Every lot has a fail-safe that has to be within our limits. If it doesn't, it's never shipped. And that happens with all vaccine production companies. And so when we produce a vaccine, it's of the highest standards going out. No different than what our human side of the business would have to do to treat our animals with. So when we vaccinate a calf, you can assure that there's a USDA licensed registered number of that vaccine. It's been through the approval process. The USDA has done the trials on it to make sure it's efficacious and safe, that it works and won't do any harm, and that the production standards are constantly evaluated to make sure that vaccine is the same thing we say it is every time.
It's very meticulous. Veterinarians help with this regulation and educating producers on making sure that we have safety that goes onto the plate of our consumers. And so with these, all these regulations, and they test the meat too, periodically. There's USDA inspectors at these processing plants that are, again, checking stuff to make sure it is very safe for human consumption. It is a big thing, and it's something that isn't taken lightly by veterinarians, by the producer, and then on down through to those that actually process the meat or eggs or milk.
How are these regulations put into effect?
When we look at the best, we have multiple ways to administer vaccines in animals. And there's different types of vaccines, and they all have fail-safes to protect any type of contamination in the food supply. We're not as worried about vaccines, but we do have the fail-safes in place. A withdrawal time is on products that may have an adjuvant, which is a carrier that could have a depot effect to provide a longer reaction. And those withdrawal times are max 60 days prior to slaughter.
So withdrawal time is just like with anything. Sometimes we hear about withdrawal times with antibiotics or anything that we're injecting into a food-producing animal. And once you inject something or give something to an animal, there is a regulation based on USDA, so the government in the Food and Drug Administration, when we could put that animal into the food chain based on whatever we're injecting. So you inject something, whether it's an antibiotic or a vaccine, you have to wait a certain time frame before they could slaughter that animal to use the meat.
When we look at injection site management, we have different routes of administration for vaccination. We use a lot of subcutaneous injection for vaccinations. So subcutaneous is we give vaccines under the skin, never entering the muscle, never entering the food that we would eat off the animal. We do a lot more, and emerging technology in vaccination is intranasal vaccinations in cattle for bovine respiratory disease. So we go ahead and give that vaccine in a liquid form, spray up the nostril. And giving up the nostril stimulates the immune system, stimulates a total protection from pneumonia. And so we use both viral and bacterial vaccines in that fashion. So we completely eliminate any depot effect or any withdrawal time on those animals, because you have just an antigen that you're just raising the numbers in the nose of bugs that are already there. And that's creating those dangerous signals that go back to the immune system that say, hey, we need to recognize this, that when those numbers blossom or bloom, we need to react quicker. And if you prep the system to do that before it reacts, you're going to have a better response. Keep the cattle healthy, keep them producing, make better use of our resources we have in Kansas so we can better feed the world.
How are vaccines created?
People often wonder how vaccines are created. And when we look at vaccine creation, it really goes back to how our industry and how the government, how the veterinarians, everybody on the front lines monitors for emerging diseases.
Specifically, there's pharmaceutical companies for animals, and they do a lot of research on these vaccines. And so when they make and produce these vaccines, it's based on antigens, meaning particles of that virus, or particles, or possibly the whole thing, if it's a modified live, to stimulate the immune system. So it makes the body recognize it as foreign. And once the body recognizes it as kind of a foreign type of an injection, then they can produce an immunity to it.
And so we would much rather vaccinate to eliminate disease than have to treat it and use a lot of antibiotics. I mean, that's our goal. And so if we constantly work with diagnostic labs, constantly work with R&D parts of all our businesses, and and when some new emerging pathogen or new emerging bacteria or virus or bug starts showing up in diagnostics in our diagnostic labs, then the first thing we want to do is go and create. We try and take it back through R&D and cycle back through, go through all the USDA approval processes about how we make a vaccine. Well, so if we look at how fast vaccines can be developed, we still have to go through trials in animals that show efficacy and safety, and those take time. Just like vaccines in people have to go through trials in people that show efficacy and safety. So even with all this new technology we have, we still are about the same pace in developing vaccines that we've been, because we learn more tests we have to do to prove they're efficacious. And we learn more things or more attributes of vaccines that we track. There's a whole technology around not only the antigen or the piece of protein that we use to stimulate the immune system, but how we can ramp up other parts of the immune modulators, things that ramp up the immune response to make it more active. I mean, most of the times when we have a vaccine lack of a response to a vaccine, it's nothing different than you and I have, where it may not be that the vaccine was any good, but we still have to have an immune response in your eye or the animal to react to the vaccine. The same reason we get sick, because we're exposed to stuff every day. We have an arm of the immune system that's constantly monitoring the environment, and it's called our innate immunity. It's the one that just has a generic response to anything that comes in, and it can break down. Then we have our acquired immunity, the part we vaccinate for, that says we're building a memory in our immune system to say, okay, when we see this, we need to make sure we fend it off. Well, it can break down too. If we look at most times you've gotten sick, it's usually been when you've been running hard, working hard, late nights, or there's been a lot of stress. All those have an effect on your immune system. And that immune system has to be in place for any vaccine to work. When we look at the development of vaccines, all vaccines are developed for use in healthy animals. That's how they're all tested. It's on every label you read. And so our goal as an industry is to have a vaccination program in place that we vaccinate those animals when they're healthy and can respond. So we build up the protection above the challenge, and it stays up here. So when the challenge comes up, our protection's still above it. And that's the basic principle. That's why we start vaccinating them when they're young, and keep vaccinating them till they get older, till they enter our production herd. And we still vaccinate them there too. So all that's based around the whole cow life cycle.
Let's talk about pathogens and diseases.
what type of things do we vaccinate animals for, and specifically producing type animals? And really it goes across all realms, whether it's a companion animal, dog, cat, or even cattle. You vaccinate one for a lot of respiratory diseases. Just like you and I in the flu. The flu is also something we're about, for instance, like the horse. They have the flu virus. Also swine flu, we've heard about that. Poultry, they also were worried about the flu in that aspect. So vaccinating for respiratory diseases. There's a lot of viruses that can cause respiratory diseases in the nose, so like sinus infection, or even deeper into the lungs. And so they're all specific, and there's all vaccines specifically targeted to protect them from that. There's the whole gamut of the bovine respiratory system and producers, whether bacteria or virus, and protecting them from those. So respiratory is a big one, and it's one thing that there's a lot of different vaccines that are out there to protect the animals from those respiratory diseases. Also the GI tract. We have different vaccines that can kind of protect them from different diarrhea type of diseases. So BVD is one of them. Bovine viral diarrhea is a virus that can cause diarrhea in cattle. But there's all kinds of different ones that potentially could cause in different species based on exposure and what's involved with that, whether it's a virus or even bacteria. So diarrhea or the GI tract is another system. The other one is neurologic. So we do have some things that can cause neurologic disease in the animal, or even quick death. Rabies is a big one. We protect animals to rabies based on they get exposed, right? Most people don't realize the amount of rabid animals that are out there in the United States as potential exposure to our animals that are out, whether grazing or just interacting with other wildlife, that is always a possibility they could get the disease. If an animal gets rabies, they die. And so protection is really crucial, and it's really protective for that disease. So that's just one that we worry about in that aspect.
Treating parasites in animals, deworming, which can have an effect on the immune system. So another effect on prevention. Animals that have high parasite loads don't respond as well to disease, or don't respond as well as vaccines. So when we look at our industry as a whole, we look at a holistic approach on. We need to make sure we take care of parasites, we take care of bacteria, we take care of viruses, you take care of the husbandry of the animals so we don't stress them with handling or care. We have them make sure we're covered, we're nutritionally sound in our plan to feed them, make sure they have all the nutrients, trace minerals they need. All those come into one big group to make sure we have an effective, safe, wholesome supply of beef.
One of the misconceptions about vaccines and diseases is that if you don't hear a lot about it, whether in the public or your neighbor has this animal with the disease, that some people quit using the vaccine because we don't hear about it, so we don't have that, exposure. That is a misconception and false. A lot of times they're still getting exposed, but they're not getting the disease based on the vaccines that we're using. And so that's why it's crucial to continue to use the vaccines that are recommended by the veterinarian for whatever diseases that we're trying to protect based on specific animals. One example would be West Nile virus. Initially, when we specifically think about like horses, for example, when it first came through, we were really concerned with West Nile and horses dying of West Nile, so we vaccinated, and now we don't hear a lot about West Nile virus, especially in horses and some in humans too, but with horses specifically, so people quit using the vaccine. But now people are still getting horses that are getting the disease itself because they're not vaccinating. They test mosquitoes all over the United States every year for West Nile, and guess what? They all have West Nile in them, those mosquitoes. So the transfer and the prevalence is always possible of getting the disease. So don't stop vaccines just because you don't hear about the disease. We don't hear about it because of the vaccines that are being used.
What are the economics of vaccines?
When we have a healthier animal based on protection of diseases, we are in turn making for a better welfare for our animals out there. They're going to live a happier life, a healthier life, and in addition, all that goes into the producer. If they're producing an animal, if the animal is healthy and happy, they're going to be a better producer for whoever owns them. For the aspect of making more money, they're going to make and produce more product at a lower cost. In addition, that will again make for safety where we don't have to use as many antibiotics for those animals if their own immune system is fighting off disease and we're not needing to put a lot of extra products in those animals. So vaccines are doing wonderful things for the welfare of the animal and for the production of the animal, right down to the plate.
If we look at how vaccines affect the cost of food to the consumer, and really this comes down to two things. If we vaccinate, it really comes down to the cost of disease. You know, a lot of times we think the cost of disease are for you or I, we go to the doctor, you know, we pay our exam fee, and then we pay for antibiotics, you know, and so we have, in cattle production, we have a labor cost to take them there to examine the animals and to treat them, and then we have a cost of antibiotics to the animal. Antibiotics run on upwards of 15 to 20 bucks a head to treat an animal for respiratory disease one time, you know, and so that's a cost. Another cost we don't think about is that when an animal's sick with pneumonia, as it's recovering, it's not gaining weight, it's not growing, it's not producing the beef that we're trying to produce in those animals. Therefore, a goal that our industry has is we'd much rather prevent disease. I mean, our whole focus is prevention of disease, so we don't have to use antibiotics.
What is the future of vaccines?
The evolution and the future of vaccines is quite exciting in, again, knowing that research is always being done on these vaccines, making the vaccines better, the ones that we already have, making and producing other vaccines that we haven't had for different species. And with that, again, is going to help potentially the producer in addition to those animals and protecting diseases. So research is crucial, and you know, for instance, some vaccines that we give maybe once a year, with more research in the way they develop the vaccine, can we give it just once every 3 years, once every 5 years, every 10 years? So we're not over-vaccinating the animal, and it's still protecting those, so less times needing to worry about injection sites and those kind of things. All those things are developing. All those type of vaccines, making them better, so the immune system is recognizing faster to produce even more of an immunity to certain diseases, viruses, bacteria. And again, just going right down to the consumer and the plate, making things as safe for the people that are consuming the meat, eggs, and milk, in addition to keeping the animals safe and protecting them from diseases.
As we look at the future of animal health companies in general, the trend going forward is strictly looking at prevention. We've always looked at prevention. We're just developing new technologies that allow us to be better at it than we have in the past. And as we look at different routes of administration, different technologies around vaccinations, better ability to track emerging diseases with our diagnostics, our goal going forward is to look at prevention of disease, and prevent. In doing so, will allow us to decrease the use of antibiotics, decrease the use of those things that could have a potential overlap in the human health.
That wraps up this episode of Real Ag. Remember, you can see every episode of this series by going to SmokyHillsTV.org. Until next time, I'm Kyle Bauer, and this has been Real Ag.
Production of Real Ag is made possible by
Servitech has been helping producers across the Midwest make the planet more productive since 1975. We are proud sponsors of Real Ag, helping tell the story of how your food makes it to your plate.
The Kansas Soybean Commission, the Soybean Checkoff, Progress powered by farmers.